Okay, we will finishing off here. Question 13. Which graph would be obtained if the measurement of x has a large systematic error but a small random error? What's the answer? Large systematic error but small random error.
I think it's C.
Okay, that's the mean value. Right? Large systematic error would mean that the average value is far from the true value. That's the true value. That's the average value, far from it. Or we call it not accurate lah. Small random error would mean that the normal distribution is small random error. They are very close to each other about the mean. Would be narrow and tall, or we call it precise. Right? You can see that they are examiner are very twist the question to differently. Okay. So this one is small random error or precise. This one is large systematic error and accurate. How about B and D? Can you describe to me in terms of random error and systematic error?
Pardon?
B and D. Describe for me in terms of systematic error and random error. B is what?
B is accurate, right?
I want random error and systematic error.
Like very
Accurate, yes. Accurate, I agree with you.
oh
But I want you to describe in terms of systematic error and random error.
low random error, low systematic error.
Oh, random error is very large, large scattering. This is flat. That means it's scattered over a large range. So large
Oh,
random
means there's a
error,
lot of random error. Oh, okay.
not random error, large scattering. Whereas the mean and the true value is almost the same. So it's a small systematic error
Accurate.
or accurate.
Mm.
How about donkey?
Okay, is high random error, high systematic error.
Okay, good. Try this one. Thermometer can be read to an accuracy of plus minus 0.5 degrees Celsius. Thermometer is used to measure a temperature rise from 40 to 100 degrees Celsius. What is the percentage uncertainty in the measurement of temperature rise? Can
Mm. Isn't it A?
nope, cannot simply guess. I must work it out.
No, teacher, but minus only one.
Minus only, yeah, you minus 100 minus 40 temperature rise. But you have to add each of them got 0.5, so you have to add them up.
Oh,
So it's 60 plus minus 1. Okay, 1 over 60 times 100 is 1.7%. The answer is donkey.
wait, 1 over 60. Oh, okay, okay.
1 over 60. Okay,
So delta X is the uncertainty,
delta
right?
x is this one. Is the 1. Delta x. 60 is x.
This one is called uncertainty, right?
Uncertainty.
Okay, okay.
This is proportional uncertainty or fractional uncertainty delta x over x. How about this one? They are given mass, length, breadth, height, and then density calculate for you. What's the uncertainty in the result? Uncertainty in this one, no? In the density. Can
Um, uh, oh, density. Okay. Mass over volume.
yeah, mass over volume. Right? Calculate for the volume first. And the percentage uncertainty for L, percentage uncertainty for B, percentage uncertainty for H, or you go with proportional, delta L over L, delta B over B, plus delta H over H, delta L over L, delta L, L, delta B over B, delta B, B, delta H over H, delta H over H, right? B is you multiply them up, all this together, 5 times 2 times 1, so that's what you get from your calculator. Then your density is mass over volume, delta M over M, delta V over V, right? 2.5 is given for density. M 0.1 over 25. This one you have already calculated out here. Right? Answer C. Can.
Oh, okay. But the problem with this is because they it's not a lot of question in past year.
This one is important in paper 5. Partial
What is
question.
paper 5?
Paper 5 is practical, written practical, where they do the where the
But practical, they hardly even ask this also. They usually ask like what's the percentage in uncertainty only. That's all. So I
paper
just take
3
the
is
average.
easy. Paper 3 is very simple error. Paper 5 is
Oh,
different. A2 is different.
oh, this paper two mostly in paper two. Oh, I
Huh?
see.
This paper 1 and paper 2 will come out. That's
Huh,
why
really? Paper two, I hardly see it. Like very very rare.
God, we try some question just to make sure you are familiar with the question. Then
Yeah, alright.
paper 5, question 2. You have to do it for graph. Each one 15 marks. Question 1, 15 marks. Question 2, 15 marks. So you have to master this one. Right, this one. The student uses a digital ammeter to measure a current. The reading of the ammeter is found to fluctuate between 1.98 ampere and 2.02 ampere. The manufacturer of the ammeter states that the reading has a systematic uncertainty of 1%. Which value of current should be quoted by the student? What's your answer? You have to consider this one, error in this one, error in this one also.
Should be B, right?
Fine. Systematic uncertainty 1%. So delta IS over I times 100 is 1%. Right? 1%. Delta I from here, take the average value, which is 2. So delta I over 2 times 100 is 1. So delta IS, right? Just cross multiply. Delta IS, 100 take it down, 2 take it up. We got this one. Then we have to calculate for this one. Right? We have calculated for this one. Now we have to get error for this part. Half largest one minus the smallest one divided by 2. So add these two together. Okay. Donkey. Can
Oh,
consider the uncertainty for this one. And then this fluctuation, take the largest minus the smallest, divide by 2. And add the two together, these two together. Okay or not?
it's just slightly confusing.
This one, it does come out once a while lah.
Okay.
Try this one. Yep. For zero voltage, right? Read the current, 1000 is 2.8, 100 is 0.6. So you got take the ratio is 4.7 now. Answer is B.
Yeah. Yeah, B.
Try this one. Percentage uncertainty in X. X is given as P minus Q. P, Q. What is the percentage uncertainty in X to one significant figure? What's your answer?
3%.
Subtract lor. When we subtract, we add the, right? We subtract this one, we add this error. Not subtract, error, we just add them, that's all. So we get this answer. And calculate lor.
C. Wait, what?
6.8%. Donkey. Okay or not?
Wait. Oh, legit, I got C. Oh. Oh, the one I got was just uncertainty, right? It wasn't percentage in uncertainty, right?
Percentage uncertainty you want.
Oh, yeah, I understand.
So it's just this one divided by that one times 100%, no?
Oh, okay. Yeah, I
Then round
understand.
off to one significant figure. Can, you're still very weak in this one.
No, because I was confused between uncertainty and percentage.
Try this one. Theory suggests that the light meter measures the intensity of light falling on it. Theory suggests this
D.
has an inverse square of D. You should be able to read that, even though this is not required in your syllabus. They can tell you, and then you are supposed to
D is
understand the
D.
maths. Answer
D.
B.
Donkey.
Donkey. Okay, correct.
Donkey.
Correct. Donkey, correct. Right. That is the equation of what is given, and then you compare with equation of straight line law. So this one cannot go to 0. If P is going to be correct, it must be parallel to donkey. Okay, good. This one, radio control car takes 2.5 plus minus 0.05 second to travel 40.0 plus minus 0.1 meter. What's the car average speed and uncertainty in this value? No need to calculate this one is 16 already. Only calculate the uncertainty. Right? No need to calculate this one.
Uncertainty is 0.15. So it's B, I think. Boy.
Right? Fractional, fractional, add them up. So it's delta x 0.1 over 40, delta t over that. Right? Use your calculator and then cross multiply. Take this one across there. C.
Wait, teacher.
Yep.
I cannot just take this 0.05 plus 0.1, man.
Cannot. This is
Oh,
divide.
because it's
This is divide,
oh yeah, sorry.
not
Oh
subtract.
yeah, I see it.
Always remember this is divide, not subtract.
If plus, then if it is like plus
If
minus, then
plus
only
or
plus.
minus, then you add the uncertainty.
Oh, if it's times or divide, you have to put dv
You have to use
over v
fractional
like that.
uncertainty, lor. Fractional or proportional uncertainty or percentage uncertainty, lor.
Oh, okay, I get it.
Right? Just to review with you. Right? These are the rules we are using. Plus or subtract, you add the uncertainty of each of them, lor. Whereas multiply or divide, you take the proportional uncertainty, lor. And power, you just use power, lor. N times delta A over A, lor. Okay, or you differentiate, lor. Differentiate the same thing. dy dA and then cross multiply to get this one back, lor. I think I will try one more and then let you do the rest yourself. You try some question 2, paper 2. Okay, what's the answer? What's the answer for this one? Diagram shows the stem of a Celsius thermometer mark to show initial and final temperature reading. What's the change in what is the temperature change expressed to the approximate number of significant figure? Yep, answer.
Wait, um 20.5. It's just B only.
Okay, good. 20.5. Okay, let's do paper 2. A student uses a micrometer screw gauge to measure the diameter of a wire. He noticed that the gauge is fully closed. The reading is not zero. State and explain whether the omission introduces random error or systematic error into the reading of the diameter.
Systematic error.
Explain.
Because it's not accurate.
No, you cannot simply say that. Systematic error,
What?
correct, 1 mark, will always be added or subtracted. Right? A constant error will always be added or subtracted from the correct value. Cannot use the word
Oh
precise or
yeah.
accurate. Explain
Right.
why the readings are precise but not accurate.
Because of the constant.
No,
Like it constantly getting like the range around that range, but then it's far from the correct one.
You have to express it better. Micrometer is a precise instrument. That means all readings are close to each other. That's why it means like precise. The readings are not accurate as it differs from the correct value. Okay, defining accurate. The next thing is define accurate. Explain what is accurate. Okay, 2 mark, 1 mark each.
Yeah.
Try this one. A student uses a meter rule to measure the length of the elastic band before and after stretching it. The length are recorded as 50 plus minus 0.1. LS is 51.5.6 plus minus 0.1. The change in length LS minus L naught, quoting the answer with its uncertainty. Subtract.
1.6 plus minus 0.2.
Okay. 1.6 plus minus 0.2. How about fractional? Change in length. Right? This is one value. This one we just calculated. What's the answer? Subtract only. LS minus L naught divided by L naught.
Yeah, 0.032.
1.6. Uncertainty in your answer in B.
Uh,
And this one B0. Right? This one BE L naught. And this is divide delta E over E, delta L naught over L naught. Right? Delta E is here, 0.2 over 1.5, 1.6. L naught over L naught. L naught is 0.1 over 5 over 50. And then we calculated our C. That's our C. Okay?
done.
Okay,
Mm.
a student takes reading to measure the mean diameter of a wire using a micrometer screw gauge. Make suggestion, one in each case, that the student may adopt in order to reduce systematic error in the reading. How to reduce
Systematic,
systematic
so
error?
ensure the thing is closed tightly.
No, no. This random error is a
Oh,
common. Check for
huh?
zero error on the micrometer or zero the micrometer.
Oh,
Allow
what
for
does that mean?
okay, no?
What does that mean?
You take initial reading minus final reading, and then subtract to get the actual value. That's why it meant I check the zero error. Or there is zero error, so you have to zero the micrometer. That's the other alternative answer.
Oh, okay.
Allow for a wire of varying diameter along its length.
Measure at different places.
Then take the average value. Take readings along the length of the wire at different points and determine the average. Allow for known circular cross-section of the wire. Yep.
What does that mean? I forgot. I mean, I don't know what it means.
Circular so you measure around the diameter take reading spirally or around the wire, then determine the average same as number 2.
Oh, okay.
Okay, calculate this one. The diameter of the wire is found to be 0.5 plus minus 0.2. Excuse me. Calculate the percentage uncertainty in the diameter. Paper 2 is a bit easier lah. Simple thing of calculation they will ask you lah.
Isn't it 0.2?
Percentage.
Oh, percent. Oh, shit. Oh, okay.
Read carefully.
Four. 4%.
Right? 0.2 or 0.02. Okay. 0.05 times 104%. Cross-sectional uncertainty in the area of cross-section of the wire. Yep.
Oh, yeah, okay. Yeah.
That's the cross-sectional area. You find radius, you have to divide this by 2. Divide this by 2. Divide the uncertainty, divide by 2 also. Can? What's the answer?
I got 1 over 16 pi.
What? This one uncertainty in area, in cross-sectional area.
Oh, okay.
8%. Okay now.
Wait. What's the working like?
Okay.
Because
There's a
you divide
formula.
by 2.
There's a formula. Right? Percentage uncertainty in area. 1/4 and pi are constant, so they don't have uncertainty. Percentage uncertainty in D times 2 square is times 2.
Oh, square is times 2.
Ah,
Okay. So pi and 1 over 4 is not included.
they are constant, so it doesn't have error.
Oh, okay. If you square root means it's divide 2, right?
Ah, half
Okay,
divide
okay.
by half times half
Sure, let's say if I have to divide by 2,
Say
must
again.
I, what if I have to divide by 2?
What divide by 2? Which one are you talking about?
The radius, diameter.
Yeah, using radius is it?
Diameter divide by 2.
Then
So
diameter
does
divide by
the
2. This one also
uncertainty
divide by
change?
2
Oh, so it's
Yeah.
0.1, 0.01.
Ah,
Oh, okay.
first 10 minutes time we are going to finish. Okay.
Okay.
The percentage uncertainty in D must be the same as percentage uncertainty in R. That's an important thing to remember. That's why you need to divide D by 2 to get R, and delta R is also divide this one by 2. It looks like we won't be able to cover. Try this one. Number 62. Volume of a fuel tank of a car is monitored using a meter is illustrated in figure 1.1. The meter is an analog scale. The meter reading for different fuel in the tank is given in 1.2. That's a graph 1.2. Meter is calibrated in terms of fraction of the tank that remains filled with the fuel. A car of 1 meter of a car uses 1 meter of 1 liter of fuel when traveling 14 kilometers. The car starts journey with a full tank of fuel. Calculate the volume of fuel remaining in the tank after journey of 210 kilometers. Yep, what's the answer? Car uses 210, there are 14 or 15 liters of fuel. So the tank has 60.
Oh, okay.
Okay, 60. Full tank, 60. Use your answer in one, this answer, and figure 1.2 to determine the change in meter reading during the journey, during the 210 kilometer journey. Right? Just read it. 45, read it. 3/4 full is still 3/4 full. Okay, can?
Yeah, okay. Can.
Anyway, these are all in YouTube. You can just refer to it when you are uncertain.
All right.
There's a systematic error in the meter. State the feature of figure 1.2 that indicates there's a systematic error.
It does not start from zero.
Yeah, doesn't pass through origin, no? Correct? The line or graph does not pass through empty zero. Suggest why this meter is an advantage to have this systematic error.
Because it's to indicate the change in volume.
No? It's good for you. If
Yeah, that's
you forgot that you need to fill up, when your tank is empty, you still got some fuel to last you so that you can go to the next petrol station. If not, you'll be in trouble. Okay?
that's true.
Okay, you won't be able to
Mm,
cover kinematics tonight. We leave it for next week.
okay.
Try this one.
But I actually need help with electricity.
No hurry. Unless you want to try electricity first, go topic by topic.
Like
Okay
the
now.
Kirchhoff second law, that one, like the internal resistance and everything.
Kirchhoff's first law and second law.
Ah,
You want me to go over there with you?
next week.
Okay, we can go 40 minutes, and then after that got time. We second period we use kinematics. Okay, try this one.
Actually, my
Yeah,
my kinematics not a big issue, but I think my momentum
I still have to review with
momentum
you
and
just to make
the
sure you are okay. Quantity and
projectile motion also.
physical quantity also you are still not clear about some of the points. That's why I have to go over with you. It's better to do it
But
slowly.
projectile motion is
We will try. We will try some question. Make sure that you know how to solve the question. No hurry lah.
yeah, but
Next week we still got another 40 minutes, and then the following another 40 minutes.
could we prioritize projectile motion and and electricity?
We go to electricity next week. And then after that, we go to try some question in kinematics, and then we go to projectile motion, no? If we have the time. If not,
Oh,
if not
teacher, I
on
forgot to
Thursday,
tell
no?
you.
Say again.
I forgot to tell you something.
Oh,
Yeah, because Wednesday is my mock test.
not important lah. Final exam more important lah.
Huh? I need to study.
I can go over with you some lah.
Can we move to Thursday? Thursday.
This Thursday projectile lah.
Projectile and the electricity.
So
The
Tuesday you don't
12.
want any class lah.
Tuesday the one.
So you want it on Thursday lah. Okay, we'll try this question.
Yeah, Thursday.
We try this question. Simple pendulum. You can see very simple calculation only. Testing you. Calculate the percentage uncertainty in the measurement of T and L. Right? Simple calculation only. Paper 2 is easier. Right? This percentage
First
uncertainty
one is
1.6%. Then percentage uncertainty in L, right? 1.1%.
yeah.
And of course, it becomes harder and harder lah. They give you a formula now to find G. Using the answer in A, calculate the percentage uncertainty in the value of G. Yep, what's the answer? Percentage uncertainty in G.
So it's just L minus T times 2,
The constant doesn't
isn't
have
it?
percentage uncertainty, only L and T, that's all. Right? So 2, the square, there's a 2 there. Percentage uncertainty in T, percentage uncertainty in L. Then put in your value. Right? You have calculated there for percentage uncertainty in T, uncertainty in L. And that's what we get, 4.2 or 4.3%.
Yeah, but it's dy though. Shouldn't it be like over delta x over x minus
No
delta y over?
minus, no minus, no minus in error. So delta L,
Because this is percentage uncertainty, right?
this one, this one error, no subtraction, always add one.
Oh, okay, I understand. All right,
Okay,
all right. Teacher, I'll see you.
almost finished already. By reference to suggest why it is not correct to code at 9.751. Right, because of the error there.